Good afternoon and welcome to TL Physics, and today I am going to talk about resolving objects on slopes. Now, we talked about in previous videos about resolving vectors and taking components, but going down a slope has a slight nuance to it. Now, what I have here is I have a box that weighs 10 kilograms sliding down a slope, and I have already drawn in the vector arrow for the weight. Now, just to recap, 10 kilograms mass is not a force. Okay, if you times it by the gravitational field strength, so in this case it would be 9.81, you will find the force. So that is the weight equals m times g, and that is going to equal 10 times 9.81, which is going to be 98.1 newtons. Now, this is not the only force acting on the slope. There is also something known as a reaction force, and this acts here. I'm going to call this reaction force R. A reaction force comes from Newton's third law, that if I put a force on object A will put an equal and opposite force upon me. So what's happening here is that this object is putting the weight on the surface of the slope, and the slope is reacting. And this force is perpendicular to where the contact is happening. So this force is acting this way because the contact is acting this way. Now, components. Now, clearly we know that if something falls down a slope, then it slides along the slope. So there must be a component of this force acting down the slope. I'm going to draw this in a red line here. And I'm going to call this F down the slope here. Okay. And as usual, there must be a force that is acting at right angles, because you can see this weight is acting at an angle here. And there must be a force acting at right angles here. I'm going to call this F of the reaction force here. And if I actually draw in, because if you look at it, it's only this weight here that's working both down the slope and at right angles to the slope. This reaction force is only working at right angles to the slope. So if I draw this weight vector here, I can see I've got the force down the slope, and I've also got my reaction here. And as you can see, if I drew the vector diagrams of these components, this down the slope and this reaction, I will have a lovely right angled triangle, and the resultant, the overall, is of course my weight. Now, solving this and working at the angles is a bit more difficult. And it's really important to remember a few golden rules. Firstly, this is the hypotenuse of any triangle you make. So if you start drawing lovely angles, so here's 48, so this is going to be 42 degrees here. This is the hypotenuse to your angle here, okay? So if I was to try and find out what this side is a little bit more difficult than you're expecting. So if I actually draw this on here, I've got 42 degrees. And of course, this would make this 48. Okay. And a really easy way to actually remember what the hell's going on is this. That if I want to find the component of the force down the slope, I'm going to use the weight, or mg, and I'm going to use sine theta, where theta is the angle on the slope. And that is going to be my force down the slope. And I can prove this to you. This 48 here is my angle of the slope. Sine is opposite over hypotenuse. So the opposite of this angle, which is the angle of my slope, is Fs over, so if I just write that a bit better, so sine theta is Fs divided by my hypotenuse, which is the weight. I know the weight sine theta equals Fs. So I know this Fs in this case is going to be 98.1 sine 48, and that is going to be 98.1 sine 48. It's going to be 72.9 newtons. So this is down the slope. To find the reaction is going to be using cos theta. To find this force in the same direction as the reaction is going to be mg cos theta. So I remember sine theta because it's down the slope. I remember cos theta because it's the reaction, okay? So this is going to be 98.1 cos 48, and that equals 98.1 cos 48, and that equals 65.6 newtons there. Now, I know that this object here is only moving down the slope. So any forces this way are going to be equal. So I know this reaction force is going to be 65.6 newtons. Now, I know the force going down the slope is 72.9. So the force down the slope is 72.9 newtons. And using Newton's second law, F equals ma, I could find the acceleration down the slope. So 72.9 is 10 times a. So a equals 7.29 meters per second squared. If there was some friction acting this way, I would take that away from my force down the slope before I use this. So this equation here is for resultant forces. Okay, so it's really important that you realise about how to draw these diagrams. If you are unsure about angles, etc., you are welcome just to remember that the force down the slope is mg sine theta because it's the slope, and to find the one acting in the direction of the reaction force, it's mg cos theta.